Hello students, welcome. In this video we will discuss the proof of Gauss theorem. So we have already seen what is Gauss theorem. Gauss theorem, but it says the electric flux through a closed surface is equal to 1 upon epsilon 0 charge inside the surface. We had discussed in the earlier video. ਤੁਸੀਂ ਉਸ ਵੀਡੀਓ ਨੂੰ ਫਿਰ ਦੇਖ ਸਕਦੇ ਹੋ। ਤੁਹਾਡੇ ਕੋਲ ਆ ਕੋਈ ਸਰਫੇਸ ਹੈ, ਕਲੋਜ਼ਡ ਸਰਫੇਸ ਹੈ, ਇਹਦੇ ਸੈਂਟਰ ਦੇ ਵਿੱਚ ਤੁਸੀਂ ਕੋਈ ਚਾਰਜ ਕਿਊ ਰੱਖਿਆ ਹੈਗਾ। ਸੋ ਵਟ ਵਿਲ ਦ ਇਲੈਕਟ੍ਰਿਕ ਫਲਕਸ ਥਰੂ ਦਿਸ ਚਾਰਜ? ਸੋ ਦ ਇਲੈਕਟ੍ਰਿਕ ਫਲਕਸ ਵਿਲ ਬੀ 1 upon epsilon 0 charge inside the surface. So we will prove this Gauss theorem today. So for that, let a point charge q is placed at center of sphere whose radius is r. So you can take it like this one. Let this be a sphere and charge is lying at its center O, and you know the radius of sphere is r. So now you know this is a positive charge, as it do not have any sign here. So this is a positive charge. So the electric field due to this positive charge will be radially outward. So let this be the point P. So electric field will be radially outward and it will be same throughout this surface. Now, according to Coulomb's law, what it say? The electric field at a point P, that will be 1 upon 4 pi epsilon 0 q upon r square and unit vector r, that is for direction you can take. Now we have to find the electric flux. So we know electric flux is what? Electric flux we have found phi is equal to the dot product of E dot ds. So ds is the area vector and E is the electric field. So we have calculated E at point P. Now take small area ds around point P. Let small area ds around point P and area vector, that is ds. Now what is area vector? Area vector we had discussed. Area vector is a vector perpendicular to area. If you have a rectangular plane like this one, any vector you draw from here, this is the area vector. If you have a spherical surface right here, so any radius vector you draw here, that is the area vector. So same here, what will be the area vector? So if you draw area vector at this point, जब तुसी area vector इत्थे draw करोगे, so area vector the direction जिहड़ी हैगी है, that will be along E. Along E, यानी इलेक्ट्रिक फील्ड के नाल ही एरिया वैक्टर की डायरेक्शन आएगी. क्यों? पॉजिटिव चार्ज इलेक्ट्रिक फील्ड रेडियली आउटवर्ड, एरिया वैक्टर परपेंडिकुलर टू एरिया, राइट. सो दोनों की जी डायरेक्शन है दैट इज सेम डायरेक्शन. एरिया वैक्टर ds lies along electric field E. Therefore, electric flux through area element ds, ਇਹ ਜਿਹੜਾ ਅਸੀਂ small area ਲਿਆ ਹੈਗਾ ds, ਇਹਦੇ around electric flux ਕਿੰਨਾ ਹੋਏਗਾ. So as we have already seen the definition of electric flux, phi is equal to E dot ds. So same here, क्योंकि ये small area हैगा, so small area d phi is equal to E dot ds. Now put the values. So E is what we have calculated here, 1 upon 4 pi epsilon 0 q upon r square. Unit vector r dot ds. So now solve this dot product. A dot b, we have seen it. A dot v, magnitude of A, magnitude of V, and cosine of angle between them, right? So apply it here. 1 upon 4 pi epsilon 0 q upon r square. This is a unit vector. So magnitude of unit vector is 1. Magnitude of area vector is ds. Angle between them, cosine of angle between them. So what is the angle between the electric field and area? So you can see electric field and area vector both are lying in the same direction. So angle is 0 degree. And you know cos 0 degree is 1. So you have 1 upon 4 pi epsilon 0 q upon r square ds. Now this is the small electric flux through small area element ds. We have to calculate the total electric flux through this spherical surface. So for that you have to integrate it. So total electric flux phi is equal to integral of d phi 1 upon 4 pi epsilon 0, sorry, it is a closed surface, so sign should be there, q upon r square ds. So now 1 upon 4 pi epsilon 0, it is constant. Charge inside the spherical surface also constant. Radius of the spherical surface is also constant, but is left only ds. So constant terms comes out of the integral. 1 upon 4 pi epsilon 0 q upon r square integral ds. So what is the integration of ds? जो तुसी integrate करना हैगा, but will you get? You are having small area ds. So after integrating you will get the total area of this sphere. So what is the total area of sphere? So total area is what? 4 pi r square. So put the value here. Phi is equal to 1 upon 4 pi epsilon 0 q upon r square 4 pi r square. So now cancel the terms. 4 pi cancelled out, 4 pi, r square cancelled out, r square. So phi is equal to q upon epsilon 0. So hence it proves your Gauss theorem. Hence Gauss theorem is proved. In the next video we will discuss the applications of Gaussian theorem. So thank you for watching.